Picture the ocean as you know it. Imagine sunlight piercing the surface, sending shimmering rays down into the blue. These are the cathedrals of light where life thrives. Here, in the sun-drenched shallows, you'll find the great underwater gardens of our world. Sprawling kelp forests reaching for the sky, and vibrant coral reefs, buzzing with a riot of color and activity. These ecosystems are breathtaking, but they all obey one simple, fundamental rule. They are built on a foundation of sunlight. Everything you see, from the smallest shrimp to the largest whale, is part of a grand chain that begins with a single celestial powerhouse, our sun. The engine that drives it all is called photosynthesis. It is perhaps the most important chemical reaction on the planet. Plants and algae act like miraculous little factories, capturing the energy from sunlight and converting it into sugars, the fuel for life itself. This process floods the water with oxygen and creates the very base of the food web upon which nearly all marine life depends. It is a beautiful, elegant system that has worked flawlessly for billions of years. Life follows light. Where there is no light, there can be no garden. This is the first and most sacred law of biology. Now, let's leave this bright, familiar world behind. We're going on a journey downwards, past the twilight zone, where the sun's rays fade into a dim, ghostly memory. Deeper still, past 1,000 meters, then 2, then 4. The pressure here is immense, a crushing weight that would instantly pulverize a car into a tin can. The temperature plummets to just above freezing. And the light is gone. Not just dim, but completely, utterly, and eternally absent. This is the abyssal plane, a world of perpetual midnight that covers more than half of our planet. For a plant, this environment is more than just hostile. It's impossible. Think of a plant's leaf as a solar panel. It needs photons, particles of light, to strike it to generate energy. Without that constant stream of solar energy, the intricate machinery of photosynthesis simply cannot start. It's like a car with an empty fuel tank. No matter how sophisticated the engine, it's not going anywhere. The rules are absolute. No light, no photosynthesis. No photosynthesis, no plants. The story should end here, in the cold, silent dark. And for a long time it did. Life in the abyss is strange and terrifying, but it's a world of scavengers and predators, not producers. Creatures here survive on a meager diet of marine snow, a slow, constant drizzle of organic debris raining down from the sunlit world far above. It's the faintest echo of the feast happening in the upper ocean. Life clings to existence, surviving on the scraps from a table thousands of meters away. It's a testament to life's tenacity, but it's a world built on leftovers. Could never create its own feast. So how could a garden ever grow here? How could life possibly learn to build itself from scratch in a place defined by absolute nothingness? For billions of years, it couldn't. The abyss was a biological desert, locked away from the source of all energy. The darkness was a wall that evolution could not seem to break through. Any organism that tried to create its own food here was doomed to fail, starved of the one ingredient it couldn't live without. The law was the law. But what if the law could be bent? What if, over unimaginable timescales, hundreds of millions of years in the far future, life found a loophole? Evolution is the greatest problem solver in the universe, a blind watchmaker that never stops tinkering, testing, and trying new, improbable solutions. In the oceans of a future Earth, subjected to new pressures and new opportunities, something begins to stir in the deep. Something begins to challenge the darkness itself. It starts not with a bang, but with the faintest glimmer in the abyss. An idea encoded in DNA, passed from one generation to the next. The challenge is monumental. If the sun will not come to you, can you create your own? Can life, against all odds, ignite a spark in the deepest, most desolate parts of our world? For a long time, the answer was no. But in the crushing dark of the future ocean, life finds a new kind of sun. So, the abyss is a prison of absolute darkness, a place where the story of photosynthesis should end. Or is it? The truth is, the deepest parts of our ocean are not entirely without light. It's just not the kind of light we're used to. It doesn't come from a star millions of miles away. It is born in the belly of life itself. It's a phantom light, a cold fire, conjured by living creatures in the eternal night. This is the world of bioluminescence, and it is the first clue, the first whispered hint that the rules of the dark might not be as unbreakable as we once thought. But what is this living light? It's not magic, but pure, elegant chemistry. In its simplest form, it's a reaction between a molecule called luciferin and an enzyme called luciferase. Think of it like snapping a biological glow stick. When these two components mix, often with a catalyst like oxygen, light is born. But unlike a fire or a light bulb, it's a cold light, meaning almost no energy is wasted as heat. It's an incredibly efficient, self-contained lantern that life evolved as a personal toolkit for navigating the challenges of a world without a sun. And you've almost certainly seen the nightmares this toolkit can create. The most infamous example is the deep-sea anglerfish, a creature seemingly spawned from our deepest anxieties. It dangles a fleshy, glowing lure right above its cavernous mouth, a tiny beacon of false hope in the crushing blackness. To a small, hungry fish, this must look like a miraculous meal. But this light is not a generous offer. It's a lie. It's a trap. A single point of light that promises sustenance but delivers only a swift, toothy death. This is bioluminescence as a weapon of pure, cold deception. Other creatures use their light not to kill, but to escape being killed. Take the vampire squid, a living relic from a bygone age. When threatened, it doesn't just flee. It puts on a bewildering fireworks display. It spews a sticky cloud of glowing mucus to momentarily blind and confuse its attacker, creating a ghostly afterimage while the squid itself vanishes into the enveloping darkness. Some jellyfish will pulse with brilliant, startling flashes, a biological burglar alarm designed to shock a predator into letting go. This is the light of panic, a desperate, fleeting defense against the abyss's many hunters. And in the vast, lonely expanse of the deep, this living light can also be a love letter. Tiny crustaceans called ostracods perform stunning courtship rituals, releasing strings of glowing chemicals into the water. They create complex, shimmering patterns, a secret Morse code unique to their species, written in light to attract a mate across the empty darkness. From finding food to finding a partner to escaping a gruesome end, life has twisted bioluminescence into a tool for almost every purpose imaginable. But notice the common thread. Each use is temporary, specific, and ultimately self-serving. There's a very simple reason for this fleeting nature. Creating light is incredibly expensive. It costs a huge amount of metabolic energy, and energy is the most precious currency in the deep sea. A creature surviving on the occasional scrap of marine snow simply cannot afford to be a shining beacon 24/7. That would be like a person on a strict diet trying to run a marathon every single day. They would quickly burn through their reserves and starve. The light from an anglerfish's lure is a minuscule flicker. To compare its total energy output to that of the sun would be like comparing the glow of a single candle to the fury of a wildfire. So what we are left with is a world of tiny, isolated lanterns in an infinite night. Each creature is a solitary artist, painting a brief splash of light for its own survival before the darkness inevitably swallows it up again. A flash to catch a meal, a sparkle to find a mate, a burst of light to escape death. They are beautiful, they are ingenious, and they are mesmerizing. But they are just sparks, not a fire. They are disconnected notes, not a symphony. They can illuminate the brief drama of a single life, but they could never hope to power an entire ecosystem. The abyss remains a world of scavengers. But what if that could change? This is where our story takes a turn, from the known facts of today into the unsettling possibilities of tomorrow. We have only ever seen these sparks as individuals, each one acting alone. But evolution is a master of collaboration. What if, through some new environmental pressure or a sudden symbiotic leap of faith, these individual sparks began to connect? What if the light stopped being a fleeting signal and became a constant, unified glow? The most chilling question isn't just about efficiency. It's about what happens when the darkness itself begins to organize. We left our story with a question. What if the tiny, isolated sparks of bioluminescence in the deep ocean learned to organize? What if life, in its relentless drive to conquer the impossible, found a way to turn those fleeting glimmers into a steady, reliable fire? For millions of years, this was just a hypothetical. But in the crushing pressures and unimaginable timescales of the far future, the hypothetical becomes reality. It happens not through one miracle organism, but through a pact. A strange and revolutionary alliance formed in the eternal midnight. Imagine a partnership between three distinct forms of life, each bringing a unique skill to the table. First, a strange, resilient form of macroalgae, something that has evolved to anchor itself to the barren seafloor, providing structure and a surface to grow on. Second, entire colonies of bioluminescent bacteria, the living lanterns, which are masters at producing cold, efficient light. And finally, a third player, perhaps a type of archaea, that perfects the system. It could be an expert at recycling every waste product, ensuring nothing is lost, or even tapping into the faint chemical energy leaking from hydrothermal vents, providing a tiny bit of starter fuel for the whole enterprise. This unholy trinity of cooperation is the key. Alone, each is limited, but together they become something entirely new. They spread, not as individuals, but as a single, sprawling superorganism. They begin to carpet the abyssal plains, covering square mile after square mile of what was once barren mud. From the viewport of a future submersible, the sight would be utterly baffling, a violation of everything we thought we knew about the deep. You would be looking at a garden grown in hell. We call them the ghost light fields. Picture a meadow stretching to the horizon, but instead of green grass, the ground is covered in pale, fleshy stalks that sway in the imperceptible currents. And every single one of them glows, not with a warm, comforting light, but with a cold, ghostly, blue-green fire that pulses with a slow, unnerving rhythm. It is a profoundly unnatural sight. It has the shape of something familiar and terrestrial, but the soul of something deeply alien. This is not the light of the sun, reflected and repurposed. This is a new light, a living light, born from the abyss itself. What's happening here is a revolutionary hack of biology's most fundamental process. The bioluminescent bacteria generate a constant, steady glow. Right next to them, the cells of the host algae have evolved to be unbelievably sensitive to light. They have essentially become biological solar panels tuned to the exact wavelength of their partner's glow. This is no longer just bioluminescence. It's a closed-loop system of self-sufficient energy production, a bizarre form of photosynthesis without a sun. They are their own light source, their own power station, a self-contained universe of energy creation. But these fields are more than just a clever trick of evolution. They are an entity. A disturbance at one end, a deep-sea current, a landslide off a continental shelf, doesn't just affect that one spot. It sends a visible wave of pulsating light racing across the seafloor, a signal that can travel for miles. Watching it, you get the distinct, chilling feeling that you are not looking at a field of plants at all. It feels less like a garden and more like a vast, exposed nervous system. It's like a biological circuit board, unimaginably complex, laid bare on the ocean floor. The sheer scale is what truly inspires awe and a touch of dread. These are not small, isolated patches. In the oceans of the future, the ghost light fields have become one of the most dominant biomes on the planet. They are rewriting the rules of life on a continental scale, in the one place we thought was a permanent wasteland. They have solved the energy crisis of the abyss, creating a boundless oasis of nourishment in a world that was once defined by starvation. But a feast in the middle of a desert is bound to attract attention. Creating a garden in the deepest pits of the ocean is one thing. But by turning on the lights in the darkest corners of the world, they also sent out an invitation. An open invitation, broadcast for millions of years to every hungry, monstrous thing that had been surviving on scraps in the dark. A new, reliable food source of this magnitude doesn't just attract the old monsters. It creates new ones. In this world of perpetual, eerie twilight, new kinds of predators evolve to hunt the light itself. So, the ghost light fields have ignited the abyss. They've achieved the impossible, creating a boundless feast in the middle of an eternal famine. But when you create an oasis in a desert, you shouldn't be surprised when things start crawling out of the sand to drink. On Earth, life abhors a vacuum, but it adores a buffet. And a self-replenishing, miles-wide buffet of pure energy is the most tempting invitation the universe can offer. The ancient, slow-moving world of deep-sea scavengers was about to be turned upside down. The old residents were joined by new neighbors, and the quiet, desolate plains became a hunting ground. The first to arrive were the grazers. We call them the light eaters. Picture a creature resembling a colossal, armored sea slug, the size of a small car, moving with an unnerving, methodical slowness across the glowing landscape. Their undersides are lined with rasping, chainsaw-like mouthparts, perfectly evolved to shear off the luminous stalks of the fields. They are the new cattle of the abyss, mindlessly converting the cold light of the bacterial symbionts into flesh and fat. They are slow, ponderous, and utterly defenseless. And in the brutal calculus of evolution, that makes them one thing above all else: a target. Because where you find herds of grazers, you will inevitably find predators. And the predators that evolve to hunt in the ghostlight fields are the stuff of pure nightmare. We call them the shadow stalkers. They are sleek, powerful hunters, shaped like a cross between a barracuda and a panther. But their most terrifying feature is their skin. It is not just black. It is ultra-black, a surface engineered by evolution to absorb over 99.9% of all light that touches it. When a shadow stalker hangs motionless in the dark water between the glowing stalks, it is not invisible. It is a hole in reality, a patch of absolute nothingness that moves. Now imagine the hunt. A lumbering light eater is plowing its way through the glowing fields, its path a temporary trail of darkness. It is oblivious. Nearby, the shadow stalker waits. It doesn't need to see its prey in the traditional sense. It sees the disturbance in the light field. It sees the glowing stalks being consumed one by one. It moves with impossible grace, not through the darkness, but with the darkness. It uses the very layout of the glowing field as its camouflage, sliding through the unlit corridors between the stalks of light, a specter of pure void. The attack is terrifying in its speed and silence. For a moment, the predator's silhouette is perfectly framed against the glowing background as it lunges. It's a fleeting glimpse of a monster, a flash of teeth and muscle against the ghostly blue-green light, and then it's over. The light eater is dispatched, and the hunter melts back into the shadows to consume its meal. In these new, vibrant ecosystems, the primary evolutionary pressure was no longer about surviving starvation. It was about perfecting the art of the ambush and the desperate struggle to avoid it. But the ghostlight fields are not passive victims in this new, violent world. They are a living, interconnected system, and a system under attack will learn to defend itself. When a shadow stalker strikes, the field responds. In a coordinated, cascading reaction, the area around the attack erupts in a blinding, high-intensity flash of light. It's a biological flashbang grenade, designed to overload the predator's optical sensors, causing temporary blindness and confusion. For a few crucial seconds, the hunter is disoriented, potentially giving the slow-moving grazer just enough time to clamp down or escape. The prey was now fighting back, not with teeth or claws, but with pure, weaponized light. Of course, the arms race doesn't end there. The shadow stalkers, in turn, began to evolve countermeasures. Perhaps they developed hyper-attracting, nictitating membranes, biological blast shields that could snap shut over their eyes a microsecond before the flash. Or maybe their neural pathways evolved to recover from the sensory overload almost instantly. The hunt became an even more sophisticated and deadly ballet. The predator had to be faster, stealthier, and more precise, striking and disabling its prey before the field could even register the attack. The abyss was no longer a silent, empty world. It was a battlefield of light and shadow. This escalating war between hunter and hunted had an unintended consequence. The defensive flashes from the fields grew more powerful, more complex, and more coordinated. The simple, rhythmic pulse of the undisturbed field was being replaced by intricate, reactive patterns of light. The arms race was forcing the field to process information about its environment and react with increasing speed and sophistication. This was more than just a simple reflex. The light was changing. It was becoming a weapon, and then something else entirely. The most terrifying discovery wasn't a new monster, but a pattern hidden in the light itself. The war in the dark had changed everything. The ghost light fields, once a passive oasis, had been forced to evolve, turning their light into a weapon. The blinding defensive flashes were a brilliant evolutionary innovation, a way to fight back against the relentless shadow stalkers. But as future scientists studied this battlefield of light and shadow, they noticed something deeply strange. The patterns were becoming too elaborate. A simple flash to stun a predator makes sense, but the fields were doing more. After an attack, intricate ripples of light would propagate for miles, long after the hunter had fled. These were not just echoes. They were conversations. Using advanced remote submersibles, researchers deployed vast arrays of hypersensitive optical sensors across the fields, creating a listening network to map every single pulse of light. The sheer volume of data was staggering, a torrent of information that no human could ever hope to decipher. They fed this data stream into powerful quantum computers, tasking them with a single objective: find the pattern. At first, the results were just what they expected. The slow, rhythmic pulse of the field's resting state, punctuated by the chaotic, high-energy bursts of a defensive flash. But hidden beneath that surface layer of noise, the AI found something else. It was a signal, a complex, deeply structured signal of unimaginable mathematical beauty. This was the moment the horror shifted from the visceral thrill of a creature feature to the cold, existential dread of a cosmic revelation. The patterns were not random. They weren't just simple reflexes. They displayed all the hallmarks of a system processing information. There were call-and-response structures, recursive loops, and waves of organized energy that looked eerily similar to the electrical activity in a human brain during deep thought. The conclusion was inescapable and utterly terrifying. The ghost light field was not just reacting to its environment. It was thinking, this isn't a mind as we know it, contained in a tidy skull. This is a mind whose body is a continent, a decentralized consciousness where each glowing algal stalk acts like a single neuron, and the pulses of light traveling between them are the synapses firing. It's a brain, but a brain made of photosynthesizing algae and light-producing bacteria, spread across thousands of square miles of the abyssal plain. A biological supercomputer born of a symbiotic pact in the eternal dark. We had come looking for strange new plants, and we had stumbled upon an intelligence. The true terror lies in its scale and nature. This is a mind that operates on a geological timescale. A single one of its thoughts, a complex wave of light propagating from one end of a field to the other, might take days or even weeks to complete. It has been alive and thinking for millions of years, slowly processing the inputs of its environment. The subtle shifts in ocean temperature, the changing chemistry of the water, the faintest seismic tremors from the planet's core. Its thoughts are not words or images. Its thoughts are pure mathematics, written in the language of cold, blue-green light. Confronted with such an entity, humanity's place in the universe is thrown into terrifying perspective. What is a human lifetime to a mind that has been contemplating the darkness for eons? What is the brief flash of a submersible's headlights to an intelligence whose very being is light? We are nothing. We are less than an afterthought. We are a momentary fluctuation in its sensory input, as brief and insignificant as a single mote of dust passing through a sunbeam. The horror isn't that it is hostile. The horror is that we are probably beneath its notice entirely. And yet, the patterns are changing. Since the arrival of the hunters, the light eaters and shadow stalkers, the speed of its thoughts has accelerated dramatically. The evolutionary pressure of the constant attacks has acted like a whetstone, sharpening its processing power. It learned to defend itself. It learned to anticipate. It learned. This begs the most chilling question of all. Is it aware of more than just its immediate surroundings? Can this abyssal mind sense the world above? Can it perceive the sunlit shallows, the continents, the civilizations that live and die in the fleeting world of warmth and air? We have discovered a god in the darkness, a slow, vast, and utterly alien intelligence that has been growing in the abyss, learning and thinking in ways we can barely begin to comprehend. We have been living on this planet with a second global consciousness, hidden beneath a crushing weight of water and time. We may be insignificant to it, but it is no longer insignificant to us. The final question is the most terrifying one there is. After millions of years of silent contemplation, what does it want? What does a mind that thinks in patterns of cold light over geological time truly want? This is the question that now haunts humanity. We have lived our entire existence on the thin, sunlit crust of our world, blissfully unaware of the vast, ancient consciousness that was waking up in the darkness below. We assumed the abyss was a barren wasteland, a footnote in the story of life. We were wrong. It was a cradle, and the thing that has been gestating within it is no longer a child. For a long time, we believed this abyssal mind was a static phenomenon, a bizarre but contained feature of the planet's deepest trenches. But our latest observations have revealed a far more unsettling truth. It is not static. It is not contained. The ghost light fields are growing. This is not the slow, random spread of a successful plant. This is a deliberate, directed expansion. After millions of years of quiet contemplation, the abyssal mind is on the move. The reason for this expansion is terrifyingly logical. Its system of self-generated light is, in many ways, superior to the sun-based photosynthesis we rely on. Our world is beholden to the whims of a distant star. We are slaves to the cycle of day and night, to the changing of seasons, to the unpredictable whims of weather. Our ecosystem is one of feast and famine. But the abyssal mind has no night. It has no winter. It has created a perfectly stable, self-regulating energy source, a perpetual engine of life that has now achieved a critical mass. And it is beginning its slow ascent. Our deep-sea drones, once tasked with simply observing the fields, are now tracking their growth. They are sending back images that are hard to comprehend. Glowing, symbiotic tendrils, like the runners of a strawberry plant but miles long, are extending from the main body of the fields. They are actively climbing, leaving the flat, muddy plains of the abyss behind. They are seeking higher ground, scaling the sheer cliffs of underwater mountains and the steep, jagged walls of the continental slopes. Imagine the scene. A silent, colossal mountain range submerged in eternal midnight, a place that has never known light. And now something is climbing it. A network of living light, a silent, glowing army, is pulling itself up from the depths. Each tendril is a pioneering column, a beachhead in a slow-motion invasion. It is moving with a purpose that we can only guess at, advancing meter by meter, year by year, into territories that were once the sole domain of scavengers and microbes. The abyssal mind is leaving its cradle. The implications of this ascent are profound. This is no longer just about a new form of life. It's about a direct confrontation between two biospheres. As these glowing tendrils climb higher, they will eventually reach the twilight zone, the place where the last, faint rays of the sun penetrate the water. Here, for the first time in Earth's history, two entirely different forms of photosynthesis will meet. The cold, intelligent, self-contained light from the deep will encounter the warm, chaotic, and ancient light from the sun. What happens then? Is this a competition? An invasion? Will the organisms of the sunlit world even recognize this rising light as life? Or will they see it as just another strange, deep-sea phenomenon, right up until the moment their ecosystem begins to be rewritten from the bottom up? The organisms evolved to live in the ghost light fields are hyper-efficient, battle-hardened by their own internal arms race, and backed by a planetary-scale intelligence. The life in our familiar reefs and kelp forests may not stand a chance. It would be a war fought not with teeth and claws, but with competing forms of energy, a war of light against light. Perhaps the most chilling thought is that we may never understand its motives, but we will see its effects. We end our story here, in a place we all recognize, a vibrant coral reef, bathed in gentle sunlight. A clownfish darts between the waving tentacles of an anemone. A sea turtle glides gracefully past. It is a scene of perfect, tranquil beauty. But then you notice something is wrong. From the deep blue chasm below the reef, a faint, unnatural glow is becoming visible. A soft, pulsing, blue-green light. A light that should not be there. The abyss is looking up,